f of x equals to what? 2x plus 3 minus 4x, right? And what is that? That is combining these two terms, negative 2x plus 3. So this is your y-intercept, and the slope is what? Okay? That is a problem. Which problem? 6G. Okay, on the purple packet. So how do you graph it? Right, graph the y-intercept, negative 3. Positive 3. 1, 2, 3. And then the slope is negative 2. So go down 2, go over 1. You can get the other point, and 2 points determine the line, right? Okay. Any more? The slope is negative 2. Okay? So it's negative 2 over 1. So you can go down 2 and then go right 1, or you can go up 2 and go down negative 1. So go up 2, go to the left by 1. You can also get the other points. Yes. Right? Because either way, it's telling us the slope is negative 2. Right? Yes. Which is?
F of x equals 1 over x minus 3.
Okay. How do you do this? First of all, you try to graph 1 over x, right? So step 1, you will graph y equal to 1 over x. What is the shape of 1 over x? Okay. What is the domain? Domain. What would be the possible x value? It would be any real number except 0, right? It cannot be 0. Am I correct? So let's start with 1, because it cannot be 0. If it is 1, then you get what? 1, right? If it's 2, you get what? 1/2. If it's 3, you get 1/3. If it's 4, you get 1/4. See that it's getting smaller and smaller and smaller, right? If it's 1/2, you get what? If x equal to 1/2, the reciprocal 1/2 will be 2. The reciprocal 1/3 will be 3. The reciprocal of 1/4 will be 4. It's getting closer and closer and closer to the y-axis, right? Okay? I'm reviewing what we have done when we graph those fundamental functions. Okay? It could be negative. When x equal to negative 1, the reciprocal of negative 1 is negative 1. The reciprocal of negative 2 is what? The reciprocal of negative 2 is negative 1 over 2. The reciprocal of negative 3? Negative 1 over 3. How about the reciprocal of negative 4? Negative 1 over 4. See, it's getting closer and closer and closer to the x-axis, right? When x equal to negative 1/2, the reciprocal of negative 1/2 is negative 2. Okay? This is just the fundamental function 1 over x. If you still not quite know about this, this is getting just by plotting point. If it's negative 1/3, it will be negative 3. Right? So this is what? This is the fundamental function 1 over x. Because your function right now is 1 over x minus 3. You start with graphing that. Okay? Yes.
Show me which numbers you inputted to get those outputs.
How to?
Which numbers you use to get points.
Okay. The input is 1. The output is 1. The input is 2. The output is 1/2. The input is 3. The output is 1/3. The input is 4. The output is 1/4.
So we're just right now we're solving for.
No. I am reviewing for all of you. Graph this because some of you told me that this function, the graph of this function 1/x, the reciprocal function, somehow is hard for you. So I'm graphing it one more time. Yes.
So what happens to -3?
Okay. So after you get this, tell me what do you do? You got this one, then you need to subtract 3, right? You got this y value, and you need to take away 3. So what is taking away 3? It's the y, right? You got the y value. So the step 3, you need to what? How do you shift it? You shift it down, right? Because looking at y equals to 1/x, you get this outcome. 1/x is what you get right now, right? And you are going to take away 3. So it's in the y direction. That's why you are shifting it vertically. But because it's -3 here, you are shifting it what? Down 3 units. So shift it down 3 units.
Do we have to plot those points on the bottom, on the third quadrant?
Of course, you have to.
So we have to shift.
You have to shift everything down.
Which point is that above 1, 1? Right by 2? Is that 1/2?
You're talking about this one? Is 1/2, 2. And here, 1/3, 3. 1/4, 4.
So basically you do 1, 2, 3, 4, and then you do halves, like fractions to get the numbers for. Okay.
It's just to get the whole graph. Actually, you can plot more points, right? But we're just choosing some simple and representative numbers to plot it. The curve of 1/x is approaching x-axis this way.
And then that's for those are all positive, and then we have to get the second one on the.
And here, x could be negative value, right? X could be positive. Think, when x is positive, the value is positive, right? 1/positive is positive, right? Yeah? What about when x is negative? When x is negative, it will be negative. Is that right? What do? You just set up this table. Okay? This is the part that you think it's needed. Okay, 1, you get 1. 2, you get 1/2. 3, you get 1/3. 4, you get 1/4. Okay, that is this part. But it could be less than 1, right? As long as it's not 0. So how about 1/2? When it is 1/2, the reciprocal will be 2. When it is 1/3, the reciprocal will be 3. When it's 1/4, the reciprocal will be 4. So the smaller the number, or the closer to 0, the higher the output, right? Okay. Well, we cannot continue. We need more space here. When x equal to -1, what is the reciprocal of -1? Is 1/-1 still -1? What about -2? 1/-2 is what? -1/2. What about -3? -1/3. How about -4? -1/4. Am I too fast? No, we have done this. Okay? Who said that? Yeah. Yes?
Okay. So do we have to graph the bottom one? I
You mean this part? You have to, because what is the domain? You tell me. What is the domain for this function? What is the domain? What is the domain? The domain is what? All real number except 0, right? Only 0 is not defined. Elsewhere is defined. So you have to grab them. Sorry? Yeah. I didn't ask you on this exam, right? But everybody should know the domain and range for every function, right? Whenever, it's just like this. What is the domain for this function? The domain for this function is what? Is all numbers that is greater than or equal to 0, right? What is the domain for this? It's all real numbers, right? What is the domain for this? It is what? All real number except 5. So the domain will be this. Right? Is that okay?
You can't use the set notation?
Yeah, you may. But we are training all of you not just using the set notation. You also need to be able to use interval notation. You need to use all. You also need to graph. So we always ask you to write the set notation, graph it, and interval notation. Okay? Is that okay now? So -1 will be -1. -2 will be -1/2. -3 will be -1/3. -4, the output will be -1/4, getting smaller and smaller, right? But never touch 0. So what about -10? -10 will be -1/10. So it's getting what? Much, 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 much smaller, but will never touch 0. Is that right? Okay. So this is just 1 over x. How do you get 1 over x minus 3? Then you have to what? Shift down. Okay?
So we just bring each point down 3.
Exactly. So this is how you do. Okay? Every point will shift down. So some of you say, well, Dr. Chen, how do I move so many points, right? It looks like it's very, very troublesome. Then you think, what happened to this graph? What happened to this graph? What is the major axis that they are approaching to? Looks like this. This is the vertical line, the y-axis. This is the x-axis. You can see that it's getting closer and closer to x-axis, getting closer and closer to y-axis, right? So if you can know where it's going to be the axis or the lines that it's approaching to, then you can graph it without any difficulty. So let's look. The 1, 1 will be shift down how many units? 3. So 1, 2, 3. So this will be this point, right? And you know it's going to get closer and closer to, because every point is going to shift down, right? But you will not graph this way. I saw some people graph this way, say, oh, it's like this. No, it's not right. Because every point is shifting down. So this approaching this line, the line that is approaching to is also being shifted down. So actually, it's going to be getting closer and closer to this line. You see what I'm saying? Every point is shifting down. Okay? And you know it's going to approach this horizontal line. Right. You will not touch it. You will not touch this line. Yeah. Once you know where is this point shift to, you know that it's going to. Are you getting this? Yes. Okay. Can you see from there? Okay. All right, and how about these? Okay, this line, the vertical line y here. Okay, you are not doing the, you only do the vertical shift, so everything shift down. You are not shifting this way. So you know it's getting closer and closer to here. Okay, so this is on this part. How about that part? -1 is going to be shift to where? -1 is going to be shift down to here. Right? Do you see? All right? So this horizontal line right now is this horizontal line, y equal to -3. It's going to get closer and closer to that line, right? It's approaching that line. And it's approaching the y-axis. Okay? The axis that is approaching to is also shifted down. That's what it meant. It was here, 0, 0. Now shift down to here. So what is the shifting here does? Every point shifted down. Okay? Alberto? Kind of okay? Yes?
When there's like 3 times parentheses 2 squared, you square the 2 in the parentheses first or multiply 3 by 2?
I see. For that 3, the factor or the coefficient in front of x squared, right? It is finding the x squared, so it's a parabola, right? And then times 3 is you stretch it 3 times. So this is the shape of the parabola.
I mean, just like order of operation wise, you multiply first or?
No, you have to do the exponent first. After you do the exponent first, then you multiply by 3, means then you stretch it. But in this exam, I'm not going to ask you any stretching. Yeah, we only do the shifting and reflecting, yes.
For, you know, we solved for y equals 1 over x, and now let's find, I guess, not the inverse, but the other part, second drawing. Is that, can we just flip the, like, coordinates, you know what I'm saying, the coordinates around?
To find the inverse? Yeah. To find the inverse, yes, you can interchange x and y.
That's not the inverse, like,
No, this is not. This is not inverse. No, that is just shifting. Yeah. The bottom one?
the one, the black
Oh, this one?
Yeah.
No. Okay.
That's not the exact opposite of the
No. The black curve here is all together for this function, 1 over x. Okay, let me ask you. What is the graph for y equal to 1 over x? What is the graph for 1 over x? It's both. Okay? It's both. Not just the top part or the bottom part. No, both put together is the graph for 1 over x. Because this part is when x is positive, and this part is when x is negative. Right? This is the x value. Is it okay? All right? Yes? Can I do number 6 on the blue packet? Yes. Which is?
Find the domain of f of x equals 3x minus 2 over x squared minus 6x minus 16.
Yeah, sure. Find the domain of f of x equals to, can you read that one more time? 3x minus 2.
Over x squared minus 6x minus 16.
Okay, what is the domain for this function? Okay, this is a quotient, right? A fraction. It is a rational expression, right? You have numerator, you also have denominator. So when you see that an expression having denominator, then you say immediately the denominator has to be restricted. What is the restriction for denominator? The denominator cannot be 0. So you say the domain is all the values of x such that denominator cannot equal to 0. Right? You see what I'm saying? I write it down in words just to help you to know what we are talking about. But a lot of time, you don't need to write this first line. You can just say, I need all the x values that x squared minus 6x minus 16 not equal to 0. And x is a real number. This means x belongs to, right? It means that x is a real number. So x is a real number. Okay? Now, how do you find out those x values? Say, well, then let me find out when x will be when this will be 0. Okay, you want to find all the numbers that's not making it 0. Let's see what will make it 0. What will make this equal to 0? Okay? Do you remember how to solve this? You factor it. Thank you. How do you factor it? Well, 16 could be 1 times 16.
Or 8 or 2.
Right? 1 times 16, it doesn't give you negative 6 when you, negative 16 minus plus 1 is not negative 6, but 2 and 8 with a with a negative sign, you get negative 8 plus 2, you get negative 6, right? So you have what? X plus 2 times x minus 6 equals to 0. Is that right? So x plus 2 equal to 0, or x minus 8 equals to 0. Right? Yes? When you have two numbers multiply equal to 0, do you remember factoring? Yes? Okay. So x equal to negative 2, or x equals to what? 8. So when x equal to negative 2, it will make denominator 0. When x equal to 8, it will make denominator 0. So those two cannot be in the domain. So I need everything except this 2, right? So I will say x cannot equal to negative 2, x cannot equal to 8, and x is a real number. Is that okay? So how did you draw it on the number line? It could be all the numbers except what? Negative 2. So you put the open circle there, and what? And 8. But all others could be in the domain. Is that right? All others could be in the domain, right? Is that right? Okay?
Wait, so you just ignore the 3x minus 2?
Numerator has no restriction. When you're talking about a number, 3 over 5, it's okay. No matter, you can have 0 over 5, it's okay. It's just the denominator cannot be 0, right? No restriction for the numerator. Not that we ignore it. It's we accept it, okay? We did not ignore it. Sorry? Okay. Is it okay now? Okay. The what? The what yesterday? The quiz. The quiz that we have?
X over 3x minus 1.
Oh,
Find the inverse.
got you. Sure. May I erase this? is x over? Okay. Right? Did you find it? You get stuck. Okay, what is the step 1 that you want to do? You let what? Y equals x over 3x minus 1. Yes? What is the step 2? Interchange x and y. Then what do you get? X equals to y over 3y minus 1. Okay? That's how you messed up? And then you try to, step 3, you want to solve for y, right? This is what you have done in your chapter 1, right? Solve a formula for a variable. Okay? Now, I want to solve for y. Now let's recall. What is the variable that I really consider is a variable? It is what? Y. So I would like to what? Collect what term? Y term. But right now they are not in term. This is a quotient, right? So we try to make the denominator, you multiply the common denominator on both sides. So, we don't need, you need to deal with the denominator. So you will multiply both sides by 3y minus 1 to get this. Okay? Why I'm doing this? Just because it's equivalent, right? But by doing this, then, it's easier for us, right? Okay, now let's see how do I do the distribution. 3y times x, 3xy. Negative 1 times x minus x. Is that right? Now you have how many terms on the left side? 2 terms. Okay? You have how many terms on the right side? 1 term. And you want to combine what term? Very good. I like it. Combine y term. Right? This is your y term. That is your y term. You need to put them together. Right? How about that term? That is not y term. Then you kick it out. Right? Okay, you separate them. So you say, let's put all the y terms on one side, all the terms not involved with y on the other side. Does it make sense? Yeah. You combine y terms. All right, now on the left side, all the terms involved with y. Now you factor it. So you factor out y. Remember that the previous test I asked you to write down the reason, right? After you combining the y terms, you want to factor it out. So you have y times what? Alberto? Minus 1, 3x minus 1 times y equals to x. Do you get all this? Yes. So now you want to solve for y, right? Okay? So you want to isolate y. How do you get rid of this? You divide both sides by 3x minus 1. So your y equal to x over 3x minus 1. Okay? Step 4. You have to conclude. So f inverse of x is x over 3x minus 1. Is that okay? Sorry? It is possible. It is possible. Yeah. Let me tell you.
So does this mean like that inverse is the same as this?
Yes. Okay, and let me tell you, this inverse is also the same as itself. This is 1 over x. Do you see this 1 over x? Right? We just grabbed this one, right? How do you find the inverse? You find the inverse by reflecting about 45-degree line, y equal to x. look, if you reflect, it's the same. Do you see that? Do you see that? Right? For this 1 over x, when you reflect, do you get the same? Yes. Okay. You have many questions. I don't think that we have enough time for, wow. But no, that's okay. Yeah. Which one? Number 12, which is? Would that be good that we focus on this discussion today? Yes. But, you know, I'm afraid that you will have too long exam on Monday. Let me see number 12. If it's... no, you're not going to have that. Yeah. No, I said already, it's not going to be covered. I think you are ready, okay? So let's go. And pass your packet to me. The graphing packet, the blue and the purple one, okay? That's okay. That's okay. That's okay. I will give you back. I want to record it and give you back right away. The packet, the graphing packet, the white one. You didn't bring it today? No. All right. You know what? You will just leave by your desk. I'm going to go around so that, you know, I don't need to pass you back. Yeah, just leave it. And the quiz is on top. Okay, put your quiz on top of your 2 packets. Your 3 packets, actually. Okay, the graphing packets. It's a very short one, just graphing. It's mainly graphing, okay? And show your work.